Rick, would like you to tell us more about your title. Uh, but just to recap for everybody else, as you're joining us, thank you so much for joining. We're trying to stall a little bit for others to join us. But while we wait, I have an icebreaker question for us. If you were to consider your teaching career to be a movie, what title would it be? Rick was the first to respond. So, Rick, do you want to tell us why you've
Yeah,
chosen
so
this topic?
so so I might change it later, but it's the first thing I could grab at. But I was thinking that uh, teaching is always a challenge to do teaching well. I mean, I've been teaching for over 40 years, and I'm still learning how to be a better teacher all the time. And I don't think we could ever build a bridge across the ocean. So in some ways, that title is about something that um, we can spend our whole lifetimes doing, but it's worth doing because to build a bridge across the ocean means that we can all meet with each other and learn together. So really, and I think of building bridges as very much the core work of teaching. And that bridge, actually, it's a couple of bridges. I have to build bridges to my students to have a good relationship with them. I need my students to build bridges to each other so they're connected as learners together, building knowledge. And I need to build bridge between the students, myself, and the subjects that we're learning. So I just like the idea of bridges, and I like oceans, so I put it all together. Well, let's hear from
Yeah,
someone else
great.
about their title.
Can I can I
So much
proceed?
for sharing. Oh yeah, go ahead.
Okay, thank you so very much. My name is Adama Gibera. I am a teacher at the Senegalese American Bilingual School, and I'm also part of the TLI Institute. Um, I'm very happy to be here today and ready to learn from everybody about cognitive apprenticeship. Thank you.
Yeah, thanks, Adama. Grace has joined us. I mean, Grace is a lot more uh what's the word? More enthusiastic person than I am. So I'll hand over to her to take this forward. But I think Deborah has shared a response, lean on me. That's a very interesting topic, and I love that, so much. Would you care to share with us why you've chosen that title? Grace, I'm handing over to you. You're muted, by the way.
All right. Deborah, I see you put a note in the chat. Do you want to talk about that a little bit? I like that title, Lean on Me. I think I can connect to that myself. Yeah. Do you want to say a little bit more about that?
Hey, I don't know if Deborah is on the call and if she wants to share about that. Hi, everybody. It's good to be here. Thank you so much, Dami, for leading the first part of this conversation. Please, how excited are we on a scale of 1 to 5? How excited are we? So, Professor John Mayom says his movie title will be Words of Wonder. That sounds like a blockbuster movie. Sounds like something I will go to the cinemas to watch. Why would you title your teaching career that? Professor Mayom, if you would like to share with us. Words of Wonder.
Yeah, thank you. I greet you all. Yeah, I have chosen that title because, when we are teaching language, normally we look at the words, and then beyond words, especially in English language and literature, we normally say that words are not just about rules or analysis, but indeed they are about magic of storytelling, and then also they carry what is called power of communication. And then, the word wonder, shows that imagination, that stories sometimes can inspire, can also remind us about that literature, and then they open the door to the new world, and then the perspective, definitely, and then possibilities. And then together, the phrases normally can frame our teaching language and literature as an adventure, where every poem, novel, and conversation can easily show us a journey into creativity and human connections in the society. This is what really I learned when I was in secondary school, and I really continue to remember that. That goes beyond just words. Thank you so much.
Oh, wow. Thank you so much, Professor John. It almost started to sound like I was listening to a thesis being read out to me. Thanks for sharing that. As we continue, I mean, for those that haven't shared, feel free to keep thinking about it and sharing in the chat as well. Deborah will still go with lean on me. I think as teachers, that's a lot of what we do. For many reasons and in many ways, our students get to lean on us. And through my career, I found that I've had to lean on them as well, because the first thing I say when I get into a class is, this is our laboratory. This is where we discover new things. I learn from you, you learn from me, we discover the world around us. So I totally agree with you, Deborah. A really great movie would be Lean on Me. And finally, before we get into the meat of the day and we call our Professor Rick, I'd like us to share. I mean, your students would describe you in many ways that you probably don't know about. I know Adama is called Mr. Jim in his school. If your students were to describe you in one word, what word would that be? So let's have those in the chat in the next 2 minutes. If your students were to describe you with one word, what word do you think they would describe you? Prosper's movie would be The Lifelong Echo. Oh, that's so good. That is so good. That is so good. And I definitely agree with you, Rick, that it's such a huge responsibility to have people leaning on us. Because if we fall, it means they fall as well. And their fall will most likely be more catastrophic. So if your students were to describe you with one word, what word do you think that would be? We have 45 seconds to go. I'm not seeing any responses in the chat. So Rick says, I hope my students would call me listener. That's a big one. That's a big one, especially in the world where we love to hear our voices. And we think that, it was from Rick we learned that teaching is listening and learning is speaking. So it's really powerful that for you to want your students to call you a listener, because it means you've been a very good teacher. Joy would think her students would describe her as resourceful. That's powerful. Resourceful. That's good. All right. While we have other people share, please share this link with your friends and everyone that needs to be here. Today's conversation is really powerful. It has helped me personally in my own life and in my life as a teacher, in my life as an education consultant, and every other thing that I've done. And I know that you will find this super, super interesting and super useful, something that you can apply to the work that you do right away. Without much ado, I'd like to invite, my professor. I tell people all the time that I have mentors in education, and this is one of my biggest mentors. I've learned so much from him about writing, especially because I struggled a lot when I was to teach my English students writing, and he helps me a lot with that. Okay, so Rick says Aja had her hand up. Aja, would you like to share something just before we invite Rick over? I'm sorry, I didn't see your hand.
Okay, thank you so much.
Okay, hi, Aja.
Yeah, no problem. Good afternoon, everyone. So my name is Aja. It's my first time. I am teaching in Senegal. So I specialize in individual and societies. I'm teaching in ENCO education, which is like in different African countries. I taught English language also as language acquisition. So I'm really looking forward to learning from all your sharing ideas and collaborating during this session. So thank you really for organizing this meeting. And if I had to name my career a title for my career, I would choose a career through curricula, through different curricula. Why did I say it? Because I've been teaching for 15 years. I started teaching in an American school, like the American curricula, where I learned a lot of things. Then I taught in a French school, like the French curricula, and now I'm in the IB. So yeah, my career was divided into different curricula, and I used to be different teacher. Thank you so much for giving me the floor.
Thank you so much for sharing with us, Aja. And Rick just put in the chat that he works with Enco as well. So I mean, there's something to connect you both as we move forward. Yep. So I'd like to hand this over to Rick. And please get out your notes, your notebooks, your pens, call your friends, your family, your enemies, everybody and anybody that needs to be in this room, because it's going to be electrifying from now on. Over to you, Dr. Rick Campbell.
Thank you,
Please
thank
put
you,
your hands
thank
together as we welcome Rick.
you. Thank you very, very much. All right, let me just share my screen and we'll get started here. All right. Yeah. Slideshow. Okay. Well, we've seen this screen and we've seen this screen. And now we're going to get so one thing before we get going here is that I'd like us to feel kind of as relaxed together as possible. And what I mean by that is I want people to feel like you can raise your hand. Hopefully we'll see your hand. And I have help here from Dammy and Grace and John Mayom and others. Because there's absolutely nothing wrong with stopping to talk along the way because these kind of webinars, we're trying to share a lot of information, but information is kind of useless unless we talk about it and try to understand it. And that only happens when people ask questions or have something to say that helps us all see the information in certain ways. So I think we're off to a pretty good start. We've heard from quite a few of you. I hope before we leave this webinar today that everybody's voice is part of the conversation. So I'm thanking you in advance for not being shy, raising your hand, and saying something. Yeah. So what we're looking at here is an idea that's been around for a long time called cognitive apprenticeship, and we know it in some different kinds of ways. But I guess I want to say one thing before we get started is that professional development, and I've been teaching, like I said before, for over 40 years. I've been through a lot of professional development workshops. And I will tell you that most of them have done me very little good. They have not been helpful because they're quick. Someone tells me, here's what you should do in your classroom. And I don't always understand how that's supposed to work. And when I try it out, it doesn't always work the way it's supposed to. And so I'm trying here to do two things in our time together. One is to talk a little bit about the concepts or ideas about how learning happens, but I'm hoping we can also have an experience of doing a little bit of this kind of work together to understand it better. So, yeah, so I'll get started here. All right. So, yeah, we all know that, learning by doing, that's what we all believe is sort of the secret, potion to making things happen in a classroom. But we got to remember that we can't do something that we cannot see, right? If I ask you to, I'm trying to think of what I could ask you to do, but if I ask you to do something that you couldn't even imagine what it looks like, it would be impossible for you to actually achieve that. So one of the reasons we see students struggling is that they can't always see the thing they're supposed to do. And so really what we're talking about is trying to make thinking visible, okay? Yeah, so we've all been through this. Do you ever wonder why, for instance, you show students how to solve a math problem, you think you did a good job, you explained it, but then you give them a test and they can't do it. Same thing, we read a story together in a literature class and we have a great discussion about it. But when I ask students then to answer a question on their own, they can't discuss it themselves the way we discuss it as a class. This happens in history class, same kind of thing. We try to teach something, a kind of historical thinking, doesn't work when we actually ask the students to do it on their own. Same thing with science, right? It doesn't matter the subject. Although some subjects, it does matter. And those subjects are subjects where you can see the thing that we're trying to do. So if I don't teach music, but I have worked with music teachers and art teachers, and there you can actually see what's going on. Or if you teach someone how to play a game like football, you can see what's happening. So that question about why is it that I do a great job of explaining something as a teacher, I think I've just been so clear and yeah, and the students are all nodding their heads and saying, yes, Mr. Rick, we really understand what you're talking about. But when I ask them to do a problem that's related to what I taught them on their own, they can't seem to do it. And we understand this in the research as a problem with transfer. Transfer is our best assessment or best indicator of when students have really learned something. If I really understand something, you can give me a new problem that I can apply that understanding to and I can solve it, right? And that's called transfer. It's bringing one kind of knowledge into a slightly different situation and being able to use it to solve a new problem or a new challenge, right? Um, so this is all just language. For instance, if you know how to drive a car, that's a particular kind of skill, right? You could probably get into a truck and figure out how to drive the truck. That's transfer. Okay. If you know how to play football, you can probably master a game like volleyball because you've learned skills about handling a ball. There's some strategy that's similar, those kinds of things. All right. So please don't hesitate to raise your hand as I'm going along here. Yeah, okay. I see we have a lot of people joining us now, which is really wonderful. Thank you. So what's the problem? How come we teach a student something and we think we've done a great job, and then when we ask them to answer a question that's the same kind of question we just helped them with, they can't seem to do it, right? That's the thing we're asking. Well, it's because, as I said before, as learners, we can't do what we can't see. And what remains invisible, is something that's a mystery. Until we see how a thing is done, we are lost. So to be successful, learners must see, especially in classroom context, learners must see the thinking that gets the job done. So when we think about playing football, I can see how the ball gets kicked. I can watch someone who's a better player than me and see what they do. The coach can show me how to move the ball down the field, how to kick a goal. And I can see that and practice it. It makes sense to me. Unfortunately, in our classrooms, we teach things that are different. So when I talk about things like football or music or art, we're talking about kind of knowledge that we call skills, right? Learn to drive a car. Someone can show us how to do it, how to shift the gears, how to, put our foot in the brakes. Same thing, we learn how to spell. We see the words. We memorize certain rules and we apply those rules with practice and we learn how to spell words. But and adding is the same thing, right? We memorize how to add. But being able to do those things like spell or read words or add numbers is not the same as trying to make sense of a mathematical problem or to understand a poem. Skills are much easier to teach and practice because we can see them and the student can see how they're doing right in front of their eyeballs, right? The problem is that what we teach mostly in schools, we think of mathematics, we think of history, social sciences, literature, mathematics. Um, these are a different kind of knowledge. They're not about skills. It's not about kicking a ball down the field. This is about thinking. And that's what we call conceptual understanding, right? These are cognitive skills, and we all know this vocabulary, right, from education. For example, we lead students through an interpretation of a story. So we all have a classroom discussion about what a story means, but the problem is when I ask them to do that on their own by reading another story, they have a harder time doing it. Same things, we help them solve a mathematics problem. Like we show them what to do on the board, and then we say, okay, here's a new problem, solve it yourself. And they struggle. Um, I think we all see this. I hope this is a common experience for most of us. It certainly has been my experience over many decades of teaching. So one thing that scientists and researchers have done, this is about, I don't know, a little over 30 years ago, a woman named Jean Lave and a man who worked with her named Etienne Wenger. They were doing research about how people learn things like how to be a tailor, right? How to be a cook, how to build furniture, and they were looking at apprenticeship. So if you want to be a tailor, then you apprentice yourself to a master tailor, and you learn about how to make a pattern, how to cut out the cloth, how to sew the cloth together, the whole different steps that together make a, a coat or a pair of slacks or pants, right? And so this kind of apprenticeship is a typical apprenticeship. This is what we normally think of. Like if I want to become a cabinet maker, I'm going to go study with someone who makes cabinets. But here we're learning a skill, a physical skill that we can watch and see. We can see that cabinet maker doing all the things he does to make or she does to make those cabinets. It's always there in front of our eyes. And it takes some practice to do it as well as they do, but we know we have them as a model to think about, right? That's a typical apprenticeship. But then somewhere along the way, researcher says, yeah, but what happens in school when we're trying to get students to think? How do they see the thinking? They can't, you can watch a cabinet maker make a cabinet, you can watch a cook make a meal, but I can't watch a mathematician think. I can't watch a historian analyze a historical problem. So we've got a problem in school in the sense that we're teaching something that students can't see. And so they came up with an idea that we have a job as teachers to be the mentors, the experts on thinking, and our students are our apprentices, which means we have to somehow show students what that thinking looks like. So it's a model of teaching or instruction that tries to make thinking visible, which changes the way we operate in the classroom. It's not just about explaining things, it's about something much deeper. Okay. Now, let me see here. Okay. So most of us know a version of cognitive apprenticeship. Most of us know a version of this because what happens in professional development, we have all seen this, is they take an idea that's very powerful and important that researchers have looked at, and they make it simple because they say, oh, teachers, we need to make it simple for them. So they can just go in the classroom and do it. They don't trust us to understand the deeper idea and figure out how to make that work with our kids in our classrooms and the subjects we teach. We are the experts. We understand our kids, we understand our subject, and we should really get a deep idea of what this practice is. But the way it gets taught to teachers quite often is as I do, we do, you do. So I get up and show you how to solve a problem, and then maybe I show it again and we talk about it, and then you get to do it on your own. But I find when I used to try to do just that, it didn't work very well. Some students were able to transfer, remember, is carrying that understanding into a new situation, a new math problem, let's say. But I found when I would just, I do, and show the students what to do and demonstrate and explain and go through this process, by the time I get to you do and ask the students to do it, at least half of the class, if not more, still could not do it. So we're gonna jump into a little bit of I do, we do, you do right now. Okay. So here you got a lovely picture of a rabbit, a dog, and a cat. All right. And what we're going to do here is look at this problem. 8 of my pets are not dogs, 5 are not rabbits, and 7 aren't cats. How many pets do I have? Oh, okay. Well, I'm going to be the teacher now, and I'm going to show you how to do this. So here we go. Very easy, right? So the first, whoops, let me just, okay. So the first thing I say is, okay, well, we know that the dogs plus the rabbits plus the cats equal all the pets I have. Well, that's easy. So let's make it look like a little algebraic equation. So D plus R plus C equals X. All right, easy. Okay, good. So I'll keep explaining this, and then we'll all be able to do this. So how many dogs are there? Well, we know that eight of the pets are not dogs. So that means for the total, if we take away 8, the other animals, that leaves the dog. So the dog is all the animals minus 8. The rabbit is all the animals minus 5. The cats are all the animals minus 7. Oh, okay. So now I know what D and R and C equal. Okay. So there,
Yeah, so,
take D.
no
Yes,
problem.
go ahead. Is someone asking a question?
Alhamdulillah. Ça va bien. Bien,
I
merci.
don't think so.
Maybe it's
Can everyone please mute?
Yeah, I'm having a hard time understanding you there. Okay. Okay.
You can go ahead, Rick.
All right. So now I just need to put this together. Here's the dogs, x minus 8. Here's the rabbits, x minus 5. Here's the cats, x minus 7. If I add that all together, I get the total number of pets. Easy, easy, easy. So I 1, 2, 3x minus 8 plus 5 plus 7 is 20. So 3x minus 20 equals x. So
Sorry, Rick.
3x, yeah.
Sorry, Rick, one moment. I'm getting some feedback.
Okay.
And we're recording this call for the sake of those that are not here. So please, if you're not speaking, mute yourself. I
I
see
just tried to
Momodu
mute.
is
Yeah,
yeah,
I just muted some people now, right? Okay, gotcha.
yeah. Momodu, please mute your mic. Thank you so much. You can go ahead, Rick.
All right. So now we can see we got, dogs plus rabbits plus cats equal the total number of pets. We add together the x's, that's 3x. We add together the numbers, that's minus 20. We subtract the x on this side. Now we get 3x minus x minus 20 equals 0. Therefore, we move the 20 over there. 3x minus x equals x. 2x equals 20. So that's easy. 2x equals 20. That's 10 pets. Piece of cake. All right. I've just showed you how to solve this problem. All right. 10 pets. 2 dogs. The other 8 are other animals. 5 rabbits and 3 cats. All right. Nice and simple. Easy. Okay. So now you have an idea how to do it. This is the kind of thing that happens in class. Yes, Dammy, go ahead.
Yeah, I was just wondering, trying to fill the room. Was I a little fast for people? Did everybody get that?
You want me to review it one more time, Jamie?
Yeah, just to be sure.
Okay.
I
So
mean,
we know,
we're not all math geniuses.
yeah, we all know from this problem that dogs and rabbits and cats altogether are the total number of pets. So dogs plus rabbits plus cats equals the total. We know that of all the pets, the dogs are part of that group, but 8 of the other pets are not dogs. So therefore, the dogs is a certain amount, right, of the total. So if we take the total number of pets, X, 8 are not dogs, which means the rest are dogs. So dogs are the total minus 8. Rabbits, the same thing, are the total number of pets minus 5, because 5 of the other animals are not rabbits. And when it comes to the cats, of the total, 7 are not cats, so therefore the cats are the total minus 7. Whatever's left after we subtract 7 will be the number of cats, right? Yeah. So we've got a formula now. This is the dogs. Dogs are the same as the total minus 8. Rabbits are the same as the total minus 5. Cats are the same as the total minus 7. So let's add the dogs and rabbits and cats. This equation up at the top, we're going to take it down here, and we're going to put in these values. So x minus 8, that's the dogs. X minus 5 is the rabbits. X minus 7 is the cats. If we add those all together, that should equal the total number of pets. Okay. So now we do this. We know we're going to pretend that all of us have been in this class long enough. We know about how to put together an equation and reduce it. So we have 1, 2, 3 x's, 3 x's. And we have minus 8, minus 5, that's minus 13, minus 7 is minus 20. So 3x minus 20 equals the total number of pets. Okay, let's get rid of the x on this side. So we're going to subtract it. 3x minus 20 equals 0. Okay, we subtract that x and we have 2x, and we add 20 to get rid of the 20 there, which puts 20 over on this side. 2x equals 20. And therefore, well, we divide by 2, x equals 10. And now we can go back. So the dogs were all the pets minus 8. 10 minus 8 means there were 2 dogs. The rabbits were all the pets minus 5. 10 minus 5 is 5 rabbits. And the cats were all the pets minus 7. 10 minus 7 is 3. So now I know that I've got a lot of rabbits, a couple dogs, and 3 cats, and they all live very happily together. How's that, Dammy? Is that better?
Yes, thank you.
Okay, great. All right, so we've got a way to solve this problem, right? Good. Now, that means we should be able to solve a similar problem. And here it is. We're going to go to a farm now. And at that farm, there's 4 cows. But there are also, if we think about the farm, there's 16 of the animals at the farm that are not goats. That sounds a lot like the last problem. There's 18 of the animals that are not sheep, and there's 20 of the animals that are not chickens. So, of course, what we need to do then is how many animals live at the farm? And what I'm going to ask you to do then is to solve this problem, which, if you look at what happened with the last one, you should be able to do. But let's see how we do as students, because I'll tell you quite often that my students, after I've explained the previous problem, will still have a problem with this one. So we're going to go into breakout rooms. So I'm going to send you into breakout rooms. It's going to take a few minutes to about a minute or so to get you all in those rooms. So please bear with me. And you'll be in those rooms for about 15 minutes with part of our team, and we'll see if you together you can solve this problem. All right. Okay, I think everybody should be back now in the main room. Yeah, and here's what we want to find out is what happened in the rooms that you were in. Um, yeah. So in other words, how did you do?
Oh, Rick, you did give me headache with this problem. I have to admit. I'm telling you, because my first problem was I know math teachers they use so many letters X and Y. I try to use different letters for every unknown animal, and then Shaila told me that you will end up having many variables. So and then I stopped there. So but I didn't even start to be honest. So it was really hard for me. Thank you.
So one thing that we have to acknowledge here, and maybe the next time we have a webinar, there's a way to do this from a technology perspective. But one thing that was difficult was when I dropped into the rooms, everybody was talking, but we couldn't see their thinking. We couldn't make the thinking visible. So when I remember I was in Adama's room and Shiloh was talking through the problem, and I wish we could have seen it up on the screen, right? How she was thinking through things. Um, and I'll tell you that in many ways, what both groups were doing just now in the breakout rooms was really a very good form of we do, sharing our confusion, coming up with different ideas. But one thing we have to do in the classroom is show all that thinking. Every student's ideas need to be up on the board because as teachers, we get to see where students are making mistakes, things they don't understand yet, and we can help them with that. But we also get to see different ways to solve the problems, and we get to learn from each other. So I think one problem today in our breakout rooms was we just had to listen, but we could not see. This is back to the problem of seeing the thinking that gets to the heart of a problem. And today we picked a math problem. I used math because it's fairly straightforward. I could have given a problem from history, right, or a problem from reading a story, but that takes a lot more time than we have in this webinar. So I'm curious to hear from what happened. Did anyone get to a final answer? What were the problems that came up? Yeah, Dammy, go ahead.
Yeah, I think that in our group we had about two answers, one from Vincent, and one from Shayla. And just like you said, I mean, both of them actually like talked us through, their process, right? And one of the things I was struggling to do while each of them were, doing that was trying to like, because of course, I can only hear them. I don't see what they're writing, or I can't. So it was, and of course, I'm not a very good with numbers. It takes me a little longer to catch up. So I got to a point, and then I realized even when Sheila started to talk through our process again, I was like, oh, I missed everything altogether. So I'm going back again to do the same thing. So I think that one challenge that came up for me was, of course, I couldn't see. I could only hear what they're saying, but it was difficult for me to catch up, because it seems fast-paced for me. But I'm sure others would also have other challenges that they would like to share.
Yes, let me make one observation from what you said. Thank you, Dammy. And that is, we are no different as a group right here, the 21 of us that are together, than a typical classroom. Some of the 21 of us are really good at math. Some of us are familiar with math. Others of us actually may be a little scared about math. It's not unusual. And that happens in our classrooms too. But if we don't take the time to listen and learn from each other, then the people who are lost stay lost. The people who know how to do it, they still know how to do it. And there's a group in the middle that sort of knows and sort of doesn't know, and we can't be sure how well they're going to do on their own if they're given a problem. And so once again, I'm going to go back to this idea that we need to make the thinking visible. So if this is a classroom, I might have had everybody get up at the board and start to work on the problem so we could see all the different ways that people were thinking about it. Maybe people could do it in pairs. And then we could talk about all the different ways people were approaching it. Now, that leads me to one final observation is to do that with 21 people, and some classes are much bigger than 21, takes a long time. We don't usually take that much time to teach a student how to solve a problem. Yes, go ahead. Hello? Yeah. I see your hand up. I don't have your name. I just have a number for you. I don't know. Go ahead. Oh, muted now. All right.
Hello.
Hello, yes.
Yeah, my name is Abdullah Cham.
Abdullah, welcome.
Yeah, I'm from Senegal.
Ah, wonderful.
Yeah, we try to do the problem with our group.
Mm-hmm.
And I have proposed one solution. Can you hear me?
Yes, I can hear you. So, and what happened? Did the solution work?
Yeah, what I understand is it was taking like it should be a transfer idea, like you said in the lesson, the explanation. Because I take understanding from the first problem you solve about animals, pets, cats, and rabbits. And in that problem, we have the given information are 4 cows, 16 are not goats, 18 are not sheep, 20 are not chickens, right?
Mm-hmm.
And the question they ask is how many animals live in the farm?
Right.
And first I have to write the equation of the problem. 4 cows, it means I have to write 4 plus 16 are not goats. If 16 are not goats, it means x minus 16 gonna be the number of goats, animals. If 18 are not sheep, it means x minus 18 gonna be number of sheep. If 20 are not chickens, it means x plus 20, x minus 20 gonna be the number of chickens. I make it equal to x, right?
Sounds good to me.
And if I, on the left side, if I add the number of x, I'm gonna get 3x plus 4 minus 16 minus 18 minus 20. I combine them, equal to x. X is a total number of animals living in the farm. And I do 3x minus x. If I bring the x on the right side on left, it's gonna give me 3x minus x.
Mhm.
And I bring all the numbers together on the right side. It's gonna
Yeah.
give me 16 plus 18 plus 20 minus 4.
Okay.
And if I do 3x minus x, it's gonna give me 2x. And 16 plus 18 plus 20 gonna give me 54 minus 4 equals to 50. The equation gonna be 2x equal to 50, and x gonna be 50 divided by 2. X gonna give me 25. So 25 animals live in the farm. That's what I found.
All right. Thank you very much for that explanation. All right.
Okay, thank you. I take my understanding from the problem you solved about
Yes.
the
Okay.
pets, cats, and rabbits.
All right.
But the
But it'd be-
difference is here, four cows, you don't need to do subtraction because you already know the number of cows.
right. Right.
Okay.
Now, so the thing that's interesting here is how many people felt like they could have done what you just did on their own, right? Um,
Yes.
yeah. And we could ask for a show of hands, I guess, but we don't need to do that. But
Okay.
so what's interesting here is as we look at
Mhm.
this, so when I went into
Okay.
when I visited people in their rooms, I noticed a couple things. Some people seem to have a solution like the one you just offered us, right? And that's always going to be true. You're always going to have some students who already see and understand. My explanation was good enough for some of you to solve another kind of problem that was very similar on your own. I also noticed there were lots of different ideas being shared in some of the rooms, and that's a good thing because that's how we get to learn together. And it's totally okay if some people are trying things out that don't end up working, because when you find out it doesn't work, it means you try something else and maybe someone else helps you, right? Um, and this is more about making thinking visible. But I will say in a lot of classrooms, we don't feel we have the time, and so we don't always take the time to let the students' thinking come out where it's visible, where we can see it, other students can see it, and we can all learn from it. I can learn from my students sharing their thinking because I can see what they understand and what they don't understand, which tells me what I need to do more of as a teacher. Um, so when we talk about cognitive apprenticeship, it's also seeing what all the students are thinking. Just like if it's an apprenticeship in making furniture, I need to see the mistakes my apprentices are making when they're trying to make a table so I can help and correct them, right? So this is a very interesting process. Um, but I'm going to walk you through very quickly one way I might show my thinking, right? And obviously, I would maybe do more in the classroom than I can show you on slides, but you can see here that so I've got this problem, right? And I think it's very much like what we just got walked through. But so I try to draw a picture, right? Because I can't see all this. I got goats, I got sheep, I got hens, and I got cows, right? So if I draw a big circle, which is my farm, and I've got goats. So I know that there's goats in this farm, and all the other animals together, the sheep, the hens, and the cows, are 16. All right, now I can begin to picture it a little bit. Okay, that makes sense. So that means if all the other animals are 16, what's left is goats. So if X is all the animals in the farm, then the goats are all the animals minus 16. Take away all these sheep and hens and cows. Okay. And now I can do the same thing. I'm going to draw a picture and show my sheep. So there's so many sheep, but I don't know how many sheep, but I know that altogether the goats and the hens, the cows are 18. So therefore the sheep are all the animals together, X, minus these 18 animals, which includes cows, hens, and goats. And the same thing with the hens, right? So you can see where I'm going here. I'm drawing a picture. I'm able to see it now a little bit more clearly that you know, the hens are a certain amount. I don't know how many there are, but I know that the other animals, the goats, sheep, and the cows, equal 20. Now, the cows already know there's 4, so the goats and the sheep together equal 16, but that doesn't really matter. I know that the hens minus 20 from the total number of animals is how many hens there are. Hens equal X minus 20. So now I'm getting a better picture of how this works. Okay, so I've got a formula for how many goats, I got a formula for how many sheep, I got a formula for how many hens. I already know how many cows there are. Nice and easy, nice and clear, right? So now I know that the goats plus the sheep plus the hens plus the cows equal the total number of animals. Okay, and this is the same thing we were just explaining to a minute ago, right? So, um, so I add them all together. They equal X. Now I got 1, 2, 3X. That's the 3X. And this is 16 plus 18 plus 20. It's a negative number, is negative 54 plus 4, those cows, equals X, right? So I've just taken away the brackets or the parentheses, added together the X's, added together the numbers, right? Okay. Now I know that 3X minus 54 plus 4 equals minus 50. So 3X minus 50 equals X. All right. So if I take away this X on this side, I'm going to get 2X minus 50, okay, equals 0. Let's add 50 to get rid of the 50 there. That gives me 2X equals 50. And sure enough, X equals 25 animals, which is what we just got an answer from before, right? So it seems to work. How many animals lived before? We said 4 cows. So the goats are 25 minus 16. There's 9 goats. 25 minus 18, that's how many sheep there are. 20 minus 25 is how many hens there are. We add them all together, that's 25 animals, right? Now, I don't know whether my explanation helped a little bit or not. But the idea is that
Excuse me, Mr. Campbell. Can we just take the explanation again, please? I'm
yes, go ahead.
lost.
Hello? Go ahead.
I said, can we just take the explanation again, please? Can you take it again? I'm lost.
You want me to take it back up to the beginning? Sure.
Yes, sir. Thank you.
No problem. So this, just to say something here, this is how, oops, where am I going here? Okay, I need to go back up to the previous slide. Come on, you. Okay, yeah, hang on. All right. But this is really good that you ask, and this is how cognitive apprenticeship needs to work. We need students to say, hey, I still don't get it. I haven't shown enough of my thinking, right, to actually help you think the same way, right? So this is exactly how it should operate in the classroom. We need to take the time to get the questions. We need a classroom where students feel comfortable asking questions, saying, wait, I still don't get it, without being embarrassed, right? It's perfectly okay. Our goal is to have everybody thinking the same way to solve the problem. So what I said is, I look at the problem and I think to myself, it's a little confusing. So I'm going to draw a picture. So this big circle is the farm, right? In the farm, we have goats. Whoops, I'm messing with my own thing. We have goats, we have sheep, we have hens, we have cows, right? And we know from the previous statement of the problem that 16 of the animals are not goats, right? So if there's this many goats, and we don't know how many goats there are, we know that all the other animals together, the sheep, the hens, and the cows, equals 16. So how many goats are there? It's the goats are all the animals together. That's all the animals here, which we're going to call X, and we subtract the 16 animals. So if we take away the 16 animals, right, what's left should be the goats, right? So goats equals all the animals minus 16. Okay. Same thing we can do with the sheep, right? Here's the sheep. We know that they're part of the farm, right? And we know that all these animals, the goats and hens, the cows, are 18 because the sheep, 18 of the animals are not sheep. So the sheep equal all the animals together, X, minus the 18. What's left then is the number of sheep. It could be 2, it could be 5, it could be 7. We don't know, right? We don't know until we account for all these different things. So this is the difficult part where we have a little fact about the goats and the sheep and the hens, but we don't know yet how to put it together. But what we're trying to do is say the goats, we can say the goats are all the animals minus 16. We can say the sheep are all the animals minus 18. We can say the hens are all the animals X minus 20. Is that clear?
Yes, it is. Thank you, sir.
Okay, good, beautiful. Thank you. So I need that feedback because I may be doing a really bad job. I need your help, right? We have to help each other. That's the whole job of teaching is working together as a team, a learning community, right? So now I've taken what was on that previous slide, number of goats, number of sheep, number of hens, and of course we have the cows, and we know that altogether they equal the total number. We know that this is the formula for goats. It's all the animals minus 16, all the animals minus 18, et cetera, right? So now we're just going to take these four things, the goats, sheep, the hens, and the cows, which equal the total number of animals, and turn it into an equation, right? So yeah, here it is. It's the same thing, it's just moved down to here. So goats, which are X minus 16, sheep and hens and cows equal the whole number of animals. Now, this, when I look at this, it still looks confusing to me. I got to tell you the truth. But I've been doing math enough that I think it's going to work, but I don't really know. I have to kind of trust it. I have to try it out. It's an experiment, right? And so I'm going to go ahead and do what I know how to do, which is how to resolve this equation and reduce it. So I can take the x's and add them together, 3x, and I take the numbers and add them together, minus 16, minus 18, minus 20 equals minus 54, and I still have the plus 4. All right. Yeah, I'm still not sure I'm on the right track, right? It's still confusing to me. I'm still not seeing how many goats or sheep or hens, but I'm going to keep going. Now I put together the negative 54 plus the 4. That brings me to negative 50. Okay. And now I'm going to get rid of this x by subtracting x on both sides. Remember, in an equation, we have to do the same thing on both sides. So take away x here gets us to 0. Take away x here gives us 2x. All right. So 2x. Now I want to get rid of this negative 50. So I'm going to add 50, which turns this into 0, but I have to add 50 on this side. So 2x equals 50. And now I've got x equal 25 animals. I'm still not sure that's right because does that make sense out of this x minus 16, x minus 18, x minus 20? So I better check and reflect on my answer, right? That's my next job. So here's the problem again. How many animals? We said there's 25. We know there are 4 cows. We know the goats are the total, which we said was 25 minus 16. That means there must be 9 goats. We know the sheep were the total minus 18. We know the hens were the total minus 20. Okay, so now I'm starting to say, okay, I got 9 goats, 7 sheep, 5 hens, and 4 cows. I got a pretty good farm. But let's make sure that adds up to 25. Sure enough, 4 plus 9 plus 7 plus 5 equals 25. I got it. Did that help?
Yes,
Is that
sir.
clear now? Yeah? Okay. Very
It sure
good.
does. Thank you.
You're very, very welcome. So now, now I could, well, first of all,
Rick, Rick,
yes, go ahead, John.
I think when you showed the thinking in the boxes,
Yeah.
I have not seen the thinking about how the X came about. You just put it right away. That's why we skipped those
Okay.
boxes. They are
Right.
somehow complicated. Thank you.
Okay. Now, see, what's wonderful is if I've got if you're my students, you're really great students because you're asking questions. And so you've just identified something, John Mayone, which is the X was confusing. So I say to myself, well, that's my failure as a teacher. I should have made sure everybody understood why I was using X and what the X meant. So this is really helpful that we talk back and forth as learners together. Yes, Dammy.
Yeah, and I also just realized that for learners to get to this point of solving this kind of problem, there are lots of other concepts they should have learned before this point. For instance, we're adding negative plus positive, and then we're getting these numbers. We are using x as variables. Before, of course, we're all assuming that all of us on this call knows, algebraic equations. We know, when you add negative plus positive, this is what happens. All of those prior knowledge are also assumed in this case. But of course, it makes sense that if you're going to solve this kind of problem, or if students are solving this kind of problems, they've mastered also all those other skills, which means that the thinking we're trying to show here is how to solve this problem. But in terms of all the other skills that they need to know, in terms of variables and all of those other things, they have mastered that before. So without having that, I think some of us are still going to struggle with this. And that just came to mind.
No, so I think what you're saying is that and this is true. I made an assumption as the teacher, but I was wrong, that we all had a common understanding of why we use X or how we do certain kinds of things. So one thing as teachers we need to do is to make sure that my students understand some of the same things that I understand before I jump into the problem. But another way to look at this is, so John Mayom just said, okay, there's some confusion about X. Now, when I'm teaching using cognitive apprenticeship, I'm making all this thinking visible. I'm writing it up on the board. I'm putting it on pieces of paper and hanging it on the wall. So one thing I'm going to write on the board today or hang on the wall is anytime we have a problem with something we don't know, we give it a name like X. We can give it any name. We could call it, Bubba, doesn't matter, but we're going to use X for now, right? So it's really interesting how the questions that students ask make us see the things we need to think and make clear, right? Very, very important. I think some hands went up here. I have to look at the chat here. Let's see. Where is it? Where is it? Yes. Yeah, so Adama, yes, need to have prior knowledge. Yes, exactly. Okay. Yeah, I see your note there. So, so I'm just sort of wondering, what else did we sort of learn from this experience? What does it make us think about some of the ways we teach? How has this maybe helped you? If it has helped you, I hope it has, because that's what we're trying to get together today. Yes, Adama.
I think it's sometimes to help students solve certain problems. It's good to use symbols as you've been drawing. You wrote names of goats and chicken, but you use circle in order to identify a specific animal that leads you to find out the number. And I have noticed that you are using like a method by elimination, and that can be also helpful that in the process of looking for the answer. So using symbols and trying to give picture to a concept, an idea can facilitate understanding for the student.
Yeah, and you said something really interesting, Adam. You said I used a process of elimination. So that would be an important thing to talk about. One way to solve a problem is through process of elimination, and we could all talk about that. That means now that the students, my fellow learners, we have a strategy called process of elimination. It's a process that will work in certain kinds of problems, right? And when we teach in this way to show our thinking, we need to not only show what we're thinking, but we need to talk to our class and say, what did I do? Why did I do it? How does it work, right? Because we're trying to make these kind of problem-solving strategies visible, right? So, for instance, this is an example of of one way of strategically thinking your way through a problem, right? Yes, John Mayom.
Okay,
John?
thank you, Rick. I am answering the question. I thought you are winding up with Adama.
Yeah.
If you are done with him, then let me come and answer the question, the third one. Okay. This has reminded and has also helped me. I have seen that the teacher, that is Teacher Rick, has used what is called modeling. Where you solved a math problem step by step while the learners were doing. That is modeling. You have also given what is called coaching, where you wanted it through the learners, and then by the learners doing the work by themselves, And then there was also some elements of scaffolding that could have been there, the way you have repeated when the other teacher was asking. Then I saw also when I read the other article, there was something called fading.
Yes.
You know, when the teacher steps back, when we go back to our MTP, then learning should happen. The learners should do it by themselves. That you gradually removed or you moved away from us, and then you left us to think independently. This is how it has helped me, and this is what I have really taken out of this learning. Thank you so much.
Oh, thank you, John Mayong. Yeah. Anyone else have any thoughts? I realize we're have been online now for quite some time, so I don't want to keep people too long. I think some people may need to go, but the most important thing, of course, is to hear from people. We only get smart by talking together. Yeah. Yes, Dr. Tafik. Yeah.
Okay, thanks so much for this very exciting presentation. I'm a member of that team that gave that solution, and let me call him our math teacher there, give a very detailed explanation of that process. So what I just want to add is that when some people that do not really, or pupils or students that don't really like mathematics, anytime they hear hex and search for hex or look for hex, it becomes a problem for us. They say, where is this hex that they have never found all these years and all of that? So if we want to change that, one can also use alternative alphabets that will represent what we're looking for. For example, I will have preferred to use alphabet A, representing all animals. So if I'm explaining to pupils, I will say, let's assume all animals is represented by A. So instead of say X. So we cannot ask the pupils to actually pick each of those categories that are given. How many cows? 4 cows. Then we talk about the first one, that is it minus 10 or so. The one that said not, those that are not, not goats, not cows, and all of that. So we use A to represent that, A minus 18, A minus 20, A minus that, independently. Then before we can now say you have identified what each of those animals represent, then let's add them together. First, on the right equals to A, because all of them means all, which is A. Then we can now go and add the other 4 plus A minus 18, A minus 20, and A minus the other, I think 12 or so. So when we now solve, using adding A's together, adding ordinary numbers together, and collecting like terms, we'll be able to get something similar to what our math teacher has given us, and what you have also given us. One observation I got, your approach actually looks like a disaggregated Venn diagram, kind of, and it added, and I think visually it's more appealing, and we make them to really grasp at least further understanding. But what I also want to add is that if you use pure algebra, as that our presenter did, we can also make it less scary to pupils by representing them by what makes more meaning in terms of all animals are represented by letter A. So thank you so much. Yeah.
No, thank you very much. And I think what you've highlighted here is really important, is making clear to the students that X is not a sacred symbol. They can make any symbol they want, right? And now the students get to have some ownership and some agency. So they say, well, I'm going to make, like you said, I'm going to make A for all animals. They could choose anything they want. They could say, I'm going to make it C for whatever, right? And And I think that's really a helpful idea. One last thing I want to remind us of too is that I used a math example just because it's fairly quick and direct, but this kind of making thinking visible, same thing if we're teaching a history lesson to trying to analyze some historical documents and make sense of history, or we're trying to interpret a story in literature, English class, literature class, or if we're trying to look at a scientific phenomena and understand how it works. Same thing applies. We have to show the thinking we do to solve the questions that come up, whether it's in a history class or science class, whatever the subject may be. Um, Unfortunately, I feel like I have to move us along because I know we're going to lose people. I put this slide in just to show that at the end of a session of making thinking visible, we should be able to put together a chart somewhat like this that shows all the thinking that happened. And we're going to hang that right on the wall so that students can use that chart. Oh, here's the things you can do to solve a problem. And we can add to that chart every time we come across a new problem or a new thing we're trying to figure out in science class, let's say. And now all around our classroom, students say, oh, yeah, there's that strategy, there's that way of thinking. That's what the teacher showed us, and now it's my way of thinking. So it's really important to work with your students and recognize and see the things that you did to solve the problem, right? Um, so we don't have time to do this, but if I did a good job, you should be able to solve this problem on your own. And I won't take the time to read it here because I think we're going to send you all these slides and you can take a look at it yourself. And you can always email me if you're if you want to find out whether you got the right answer, right? So the question is how many seats are in the stadium, right? So I picked a very different kind of example. Um, but it's really the same kind of problem. But believe it or not, students quite often will not know how to solve it. They solve the farm problem with the cows and the sheep and the goats, but this is about soccer. I don't know how to do that, right? But of course they do if we've taught them properly. So we're not going to take the time to solve this, unfortunately. Um, these are just some notes. And I think the most important note here is that we need to know when we're getting stuck and how we're getting stuck. And we need to talk about that as learners together as a community. And then we get to get smart together. All right. I'm only as smart as the student who's struggling the most. And so when I get that struggling student to think the ways that is going to help them solve the problems, then I know we're all smart together. And that makes a huge difference, right? I set up this little chart. You can look at it later. It shows us the common way we do, I do, we do, you do. And these are some ideas about what I tried to do during our time together. And this is just another note. The role, metacognition is a fancy term. I know many of you have heard it. You know, we read about it in education. All it means is thinking about our thinking, which is what we tried to do a little bit of today, which is reflection. We need to build reflection into our classrooms. Sometimes when I'm teaching students how to solve a problem, I will stop for a minute and say, take out, on a piece of paper, answer these questions. Where are you stuck? What do you feel you know? What questions would you like to ask? So we're thinking about our own thinking, where we may be stuck and what we're feeling good about, and we can share what we've written. And now we get a chance to talk together as a class and reflect on these things. Very, very important. And you'll see that I have links to all these different readings that are part of this presentation. So reflection is necessary for learning. When we make our thinking visible, we offer a model. And as John Mayom says, modeling is what it's about. And it's no different than the way we learn to play football. We see how something is done, and then we practice doing it. And you know as well as I do that, developing your skills on the soccer field and the football field takes practice. Not every time you try to kick and score a goal do you score that goal, but you can see what you've done. You can see how you can correct it and do it better. So, and what you'll find with these slides when you get them is these are some key readings that you may find very helpful. The first reading is actually all about cognitive apprenticeship, which has been around for over 30 years. You can see this original article was published in 1991. I think we're going to that's the end of the line. Dammy, do you want to add anything here, or Grace or Adama? Adama, yes, please, go ahead.
Yeah, I would like to thank everybody for joining us today, and thank you, Rick, in particular. You have proposed math problems, even though we are all math teachers. But the most important thing is the process through which, like when you model and you scaffold and you guide the students, it might take time so that they practice to make their thinking visible. But if we follow these steps and we engage the student in such kind of activity, the more we do it, it will help us to help our students make their thinking visible that can lead to deeper understanding. So if Dami is still among us, I would like to tell him if you can still share the link that leads to the Google Classroom, because I wanted to remind all our participants that we have a WhatsApp group and we do have a Google Classroom also, where we share resources in order to continue learning. And then feel free to engage discussion based on the topic on the study today in the WhatsApp group. If you come up with questions, feel free to share. We in TLI, we will try to provide answers. And even those who are members, answers shouldn't come just from the TLI member. We are colleagues, so we co-construct knowledge. You are all invited to share problems. If any of us have the solution, we would be very pleased to share our point. Thank you. Demi, are you among us?
Is Dami still here?
I think he said he would be he had some things to do. But for those who you guys all have received the invite for the meeting, there's a link where you should register. So if you're not part of the WhatsApp group, let us know through the person who your contact person. In Senegal, it's me. We have Demi, Grace, and John Mayon and Emmanuel. So let your contact person know so that we can make sure that you join our WhatsApp group and the Google Classroom so that you can have access to all resources that we're sharing. As we all know, sharing is caring, and at TLI, we care about you.
Yeah. And Kudzai as well. I'm not sure you mentioned her name, but yes, Kudzai
Yeah,
as well. So
exactly.
yeah,
I'm sorry, exactly.
right. No, that's fine. Right. So we are a group that comes from many different countries: Senegal, Nigeria, Zimbabwe, South Sudan, Uganda. It's quite exciting, actually. So thank you all for being part of this. You will get the slides. I would also like to send you a quick and short survey. I would love some feedback and advice so we can make these webinars even better than they are. I'm still learning how to run a webinar that's as interactive as possible, and it's difficult for me anyway. So anyway, in the meantime, I wish you all a very good evening, and the weekend's coming up. I hope you have a good weekend, and I send you hope and encouragement in our lives as teachers. We do the most important work there is in the world, right? We set the basis for people's future lives, our students, and that's what could be more important than that. So thank you all for being teachers, and thank you for joining us. All right.
All right. I would ask everybody to turn on their camera so that we can take a final picture. Please, guys, please.
Camera,
Thank you.
camera. Thank you, Adama.
All right.
We see more coming on. There we go.
All
I see
right.
Mr. Emmanuel. I see Bull Abraham. Yes.
It's good to see names, but it's also good to put a face on names.
Yes.
All right. So thank you. That's it. Thank you so much.
Okay. Take care now.
Bye-bye.
Bye-bye, everybody.
Screens go dark, the session's done.